Welcome back everyone, Patrick here, moving on to the next video. So we have to simplify each of these expressions here. So notice these are fairly complex expressions formulas, and these are actually time value of money formulas. So in this video, we're more so going to focus on the algebra, practice the algebra, and then in future units in the course, we'll actually go over what these mean and how to apply them to actual problems. So here, this is strictly going to be algebraic. So starting with number one, we got 1,000 times 1 plus 0.08 times 62 over 365, all in brackets. So this here, this is actually a future value formula, if you were wondering. Again, we're just going to focus on the algebra. So what you would do with this is you'd have to first deal with the bracket. You would use BEDMAS, and then notice we got 1 plus these two expressions being multiplied. So you'd have to do the multiplication first within the bracket before adding the 1. So we would have 1,000, 1 plus, now if you take 0.08 multiplied by this fraction, 62 over 365, you would end up with 0.0136 if you round it to 4 decimal places. And then what you could do, you could add those two expressions in the bracket. So then we'd have 1,000 times 1.0136, like that, after we add these, and then you can multiply these two, and we would end up having this times that would give you 1,013.6, like that. This is actually going to be in dollar terms. This would end up being a dollar value, so this would be 60 cents over here. But again, we're not applying it yet. We're not applying these formulas yet. We're more so working on the algebra. So that's the answer for number one. That's the steps in which you'd go about doing something like that. Now over here, number two, we got 1,000 divided by 1 plus 0.12 times 120 over 365. This here is actually called a present value formula. And so what we would have to do, notice we got this divided by this, but this is like a bracket, a big bracket over here. So we'd have to first simplify this denominator. And so before adding these, we'd multiply these two. And so what we would have is 1,000 over 1 plus, now 0.12 times 120 over 365. That would give you 0.0395. And then you would add these two. And then you would be able to divide them. And when you divide these, you'd end up getting 962 approximately. Now, if you don't want to round this too much, these values, then what you can do is at this step here. I'm keeping it to 4 decimal places in both of these examples. But when you do both of these multiplications, if you don't want to round it too much, maybe the solutions you're going to be looking at have more rounding decimal places, then you can just up the number of places that you would round there and right there. Now moving on to number 3, this is a more complex expression here, and this is actually the present value of an annuity due formula. And so what would happen here is, notice we got this big bracket to deal with, but while we're dealing with this bracket, we could actually deal with this bracket too. So what we can do is we could add both of these. So this would be 1.05 over here. And then in this big bracket, what we're going to have to do is simplify this numerator first before dividing by this denominator. So this, you would simplify this bracket, 1 plus 0.05. It's actually the same as here. And so this would end up being, this could be like your next line. I'm just going to write it over here just to save some room. We'll have 1.05 to the power of 10. And then you have to do this exponent here before subtracting that. 1.05 to the power of 10 would give you 1.6289 if you round it to 4 decimal places. Then we'll have the minus 1 over the 0.05. And so continuing this, we would have 60 times 1.05. Now, when you subtract both of these, you would end up having 0.6289, right? 1.6289 minus 1 gives us 0.6289, and then we're going to be dividing this by 0.05. And when you do that there, when you divide by 0.05, this bracket would end up being 12.578. And so then you just end up multiplying these expressions, and when you do, final answer would be 792.414. Right, so that's the answer to number 3. Now number 4, probably the most complex out of all of them, this here is called the present value of an annuity formula. And what makes it complex is this exponent -10 here. So this is one way that it's shown. A lot of these formulas sometimes too, they'll take this 0.05 and they'll factor it out and put it under this. This is not to get into too much detail again about what this actually means. This is a cash flow here. So you could have this cash flow over, and then this is an interest rate, 0.05. And so you put this under here, and then you'd end up with 1 minus 1 plus 0.05 to the power of -10. So both of these are the exact same thing. It's just another format that you might see this in. And then actually what you want to do is another format this could be in, this -10 we can bring down. Remember, if we have some kind of expression to a negative exponent, that's equal to 1 over that same expression to the power of the positive exponent. So in this case, the a is this entire 1.05, and then this is the negative exponent. So another way to write this would be 60 over 0.05, and then this would end up being 1 minus 1 over 1 plus 0.05 to the power of 10, close bracket. So all three of these are the exact same thing. In fact, this personally is my favorite format, right? Because I don't know, it just makes things simple when we have just a positive exponent to work with. And so from here, what we can do, I'm going to erase this. If we continue this up here, the 60 over 0.05, let's leave for now. And then we'll have 1 minus 1 over, now this is 1.05 to the power of 10. If you remember, we did that up here as well. That's going to be 1.6289. It's just different now because now it's in a denominator. Another thing I want to mention is this 0.05, if you didn't factor it out, you can take this whole thing and put it over 0.05. That's another way this could have been shown, right? So what we do is we just take this expression, put 1 over that. All of that would still be in the numerator. So just to show it more clearly, we'd have 1 over 1.05 to the power of 10, and that would be all over 0.05, right? So this bracket here, this is another format it can be in. But again, just not to combine these fractions, this 0.05, I factored it out, and then I put it over the 60. But whichever way you do it, you should get the exact same value that I get at the end. Just make sure whichever way you're doing that you are getting that same amount. And so continuing on, when we take the 60 divided by the 0.05, we would end up with 1,200 in this bracket. Then over here, what you want to do the division first here. So 1 divided by that would give you 0.6139. Then you could subtract these, that would be 0.3861. And then you can multiply these expressions, those brackets. Final answer for number 4 ends up being 463.3